It'd be better if they made it so any fight over 100 players didn't have tie-dye. I've definitely been in fights with over 100 players without tie-dye. It really depends on where you are. I would say 1,000 players is probably where you start to hit tie-dye. Honestly, I don't think players quite appreciate how amazing tie-dye actually is, like as far as the technology goes. Without tie-dye, the servers tend to crash when you get 300 plus players. Well, I mean, I think that probably the server could do pretty good at bigger numbers now. Like 300 players was like back when tie-dye was first introduced, and the servers have gotten stronger and stronger over time. But, you know, the big thing is that, yeah, we can always bring more players, right? I wish they put these resources into less tie-dye. That's not possible. The classic, they're not working on the same thing is absolutely true. The people that are working on things like the graphics rendering engine is not necessarily the people that are working on tie-dye. The key here is that tie-dye, in particular, is actually a server-side phenomena. So all this graphics rendering, all this like extra doodads, the skins, all that stuff, none of that really impacts tie-dye, because none of that is part of the actual like gameplay simulation. Tie-dye happens because, so EVE Online takes place in a 1 second tick. So every single second, I like to say that, so EVE Online is a turn-based game where every second, like you get to take a turn, and if you do not take a turn within that second, you auto pass at the end of that second. So every single second, it takes in all of the commands and all of the choices and all of the signals it's received from all of the clients, and it updates all of the states. You know, it calculates all of the shots, all of the movements, all of the physics, all of the whatever, and then distributes out all of that, the new state, to every single client that's attached to that server. And it does this every single second. So you're saying that all these graphics, et cetera, do not have a server load? Absolutely not. No. Because on a server level, it's all just data, right? Where you are, where you're headed, what your health is, et cetera, et cetera. So when you like hit F1, you send a signal to the server that says, hey, I want to start shooting my gun. And that's your turn. That's your action for the turn. So then when it's processing all the stuff for the server, it says, okay, well, this gun is now firing, and, you know, it determines whether or not it hits and all that stuff. And then, like I said, it distributes out the state to all of the different clients. And then the next second it does it again and again and again. Now, the fact that your ship is in hull is something that the server is monitoring and putting out there. Like the fact that you are at 98% hull with 0% armor and 0% shields, that is held on the server state. You just took damage. You're now at 98% hull. Sends that out to you. Your client receives that information and goes, okay, I'm at 98% hull. And your client says, okay, well, since I'm in hull, the graphics engine goes, we get to show off the fire stuff. And so your client adds the fire stuff and whatnot to your actual ship via the graphics engine. None of that happens on the server. The server only cares about the fact that you are at 98% hull. Does that make sense? A good example, a good way that you can actually tell this, and like the difference between the disparity between your player or your client's experience and the server's experience, is things like going into warp. If you're completely stationary, you are just a ball and a vector. So if you're completely stationary, you're technically pointed in every direction at the same time. So if you attempt to warp forward, your client, it makes sense. Your ship can move, right? And if you're trying to move, like if you start moving and then you click to move a different direction, your ship will slowly arc in that direction based on your agility. But if you're completely stopped and then you double click backwards, what happens? Your ship whips around super fast, faster than it possibly can, because the direction that your ship is pointing is actually something that the server doesn't really pay attention to. Your orientation as a ship actually exists on the client side, and the client is attempting to show you the current state in the most logical way possible. The most extreme version of this is like when you have capitals or freighters and you web them into warp, or even if you don't web them into warp, because the ship is attempting to align, and it's like it thinks it's moving slowly, and you enter into warp, the server tells you that you're into warp, and now you're in warp like sideways, right? Because the server actually doesn't think of you as being sideways. They only think of you as going in that direction. It's the client that is now out of sync with your current state, and it's trying to get you there. It tries to fill in all of the different gaps. It's why, like, when you double click in space, it might take a little bit for it to actually like recognize it, because that's the difference between your client trying to show you something and the server's updates actually like validating that things are happening. If your client locks up and slows down and is laggy, that could be caused by the fire or skins or whatever. But tie-dye specifically is only server calculations, because what happens is, like I said, it's every tick. So every tick, it has to do all of the calculations for that second. So the question then becomes, what happens when there are more, when the server takes more time or has more things to process than it can process in 1 second? So let's say, just for the sake of argument, the server can process 1,000 transactions a second. Now that is wildly low, okay? But I'm dumbing things down for our dumb human brains. Computers can process millions of transactions a second usually, right? But let's just say, for the sake of argument, it can process 1,000 transactions a second. And then suddenly, because there's a big fight going on, it now has 1,500 actions a second, or 1,100. Let's go with 1,100 actions per second. So now it can do 1,000. So at the end of that second, it's like because time flows independently of the server, right? Like time is not controlled by the server. So like a second will pass either way. And at the end of that second, the server will have processed 1,000 out of those 1,100 transactions. Now, transactions happen because when it receives instructions from the server or from a client or whatever, it puts it on a stack. Now, it's not just hitting people hitting F1 or whatever. It's other things too, like NPCs making decisions, drones doing things, et cetera, et cetera. Anything that's happening, it has a transaction in the server. So, you know, those numbers can go up pretty quick. So at the end of that second, it still has 100 transactions left in its buffer, which does two things. One, it makes it so that if it tries to distribute out the information to the clients, it's missing some, right? 1/10 of all of the transactions didn't successfully get processed. This causes things to fail. This causes modules to fail to turn off or on. So then another second passes and it gets another 1,100 transactions. And now it's at 200 transactions after it's done processing another 1,000. And this buffer is actually every single second getting bigger and bigger and bigger. And that buffer exists in memory. And if you've probably heard of like a concept of like a memory leak, right? A memory leak is when something is stored in memory by a program and then it fails to clean it up after it's done with it, right? So like, let's say we have a routine that happens in a game or something like that, and it creates so many objects into memory in order to process its stuff, but then it doesn't delete those objects. They just kind of get lost into memory. That memory stays reserved with that information in it. And then when that transaction happens again, it doesn't go back to those memory spots. It creates all new memory spots. So every single time, it just keeps adding and adding and adding to the amount of memory it's consuming until the entire system fails and you run out of memory, right? That is what a memory leak is. So in this case, you actually don't have a memory leak because, you know, these transactions haven't been finalized yet. They're still living in memory, but it just stacks up further and further and further and further. So the server continues to become more and more problematic, not just non-responsive, but actually failing to process transactions in time, losing track of things, and losing track of state. And eventually, the entire thing black screens because it doesn't get its proper updates. And eventually, that memory fills up and the entire thing crashes, right? That was the experience of EVE Online prior to tie-dye. So what they've done is now they monitor, like the server monitors its own load, right? And once it realizes that it's going to start having a problem getting all of the transactions finished within a second. Like, let's say once it gets to about 70% load level, right? Then it goes, oh no, I am dangerously close to having a problem. Like if a fleet jumps in right now, jumping into a system is one of the heaviest transactions you can have. So like if a fleet jumps into the system, right, that's why like Tidi will spike if somebody jumps in, like a fleet jumps into a system and then will like go back down. It goes, okay, well, like I am critically low on time, right? Like if too much more happens, I'm going to run out of my ability to do all of the transactions in a single second. So what it does is it extends the simulation's concept of a second beyond a second to give it enough time to process each second of simulation. And that is what we experience as tie-dye. So as more and more transactions come in, it gets to the point where maybe it takes 2 seconds to do all of the transactions for a second. That would be like 50% tie-dye, so on and so forth. That's the point here, is that like tie-dye is effectively the server failing to keep up gracefully. So there are 2 ways for them to fix it. Well, there are a few ways for them to fix it. There are 2 significant ways. I'm sure if they rewrote Eve from scratch, they could do this all without compromises. No, because like I remember when, what was it? It wasn't Ark. What was that game? New World, right? When New World came out, it was like Amazon's thing. So Amazon Web Services. Do you remember back in the day when games came out, day one, you just could not play them? Do you remember when Diablo 3, I think it was, first came out? It was just completely unplayable because of the fact that it had an online component. It was a big issue because like you couldn't even play it offline because it required you to be able to go online, and it just crushed the servers. And this was true about any successful online game, any MMO, any, especially expansion packs, etc., etc. On day one, things were awful. And the problem is that with all games, you know, every time that like a big popular game comes out, like within a month or so, they go, oh my God, it's fallen off 90% or whatever. Like this is a very common thing within games because the amount of server force, the amount of server power that it takes to process everything on day one, the number of players that are trying to connect on day one, is not the same number of people on day 30 that people will stop playing for even the best of games. As a company, as a game company that has a server-based infrastructure, the question then becomes, how do I have both the server power to handle day one and also the server power, like I don't expend too much, like if I have enough server power to handle day one, I have wasted my money on every other day of that system's life cycle. And so if you've noticed, a lot of games actually have some pretty, like launches have gotten a lot better recently. In the last 10, 15 years, game launches have become a hell of a lot smoother. And one of the things that have led to this is Amazon Web Services. So Amazon Web Services, it hosts almost 60% of the internet at this point. And it's not just Amazon Web Services anymore. Like Microsoft has their own version, a few other people have their own version, but like Amazon was the first one to really do this, where you can host your stuff on their servers, and then they dynamically allocate more servers to the problem depending on load, and then remove them as they're not necessary. And then you only pay for the amount of server load that they end up using, right? So now I can have a game that is responsive on day one and is lean on day 30. And that has led to a lot of more successful launches. So Amazon then decided to try to like fix this problem, because this idea of like, well, when everybody gets together at once, servers creak and die. In a lot of these cases with games and stuff like Diablo 3, it's not like you have 100,000 people in a single game instance. Those servers were dying just managing logins and just managing basic authentications and matchmaking. An individual session will only have a controlled number of people in it. But and World of Warcraft is a great example, right? Where the way they handled things is that as you move within areas of World of Warcraft, you kind of move between server areas. And you may not even realize this is true, but a big example of this was like, I remember when the Encourage Gate opened up in World of Warcraft. And this is why a lot of times when it comes to MMOs now, if they're going to have like a live event, they tend to try to have it be distributed. Because as soon as you get everybody in one place, now you have a bottleneck. Because there's only so much you can distribute when everybody's on the same server. Because like, here's the problem. If you, there's what's called a race condition, okay? In programming, we have what's called threads. So, you know, in a lot of places, there's going to be just like the main thread where, and that's processing all of your graphics. It's processing all of your major stuff. Like when you write code and you just da-da-da-da-da, it's just all running on one main thread. And it just, even though the code, you can jump between things in code, as it's executing things, it is doing one transaction at a time and working its way through it on that thread. However, you can do what's called multi-threading. So like I was an Android programmer for a while. Database transactions and internet transactions are very timely or time-costing transactions. A database takes a few microseconds for it to respond, or milliseconds sometimes, or even a second. And of course, internet servers have a tendency to take however long they want. If you like say, hey, get this information from this server, like if you do an API call in an Android app, and you just put it on the normal main thread, the entire application locks up. You know, if you've ever seen an application stop responding, that's what's happened. There's some sort of process going on in the background that has now taken too much time, and that's happening on the same thread as the main UI. And so now the entire application can no longer respond. And Android works where if it's detected that an application hasn't responded to a UI action in 3 seconds, then it delivers a message to the user saying it's no longer responding and asks you if you want to close or wait, right? That's what's happening. And it used to be a lot worse because when you did Android programming, they let you do transactions like that on the main thread. Nowadays, actually, Android forces you to do those kinds of transactions on a separate thread. But so like what would happen is I want like, okay, so I'm going to do an internet transaction. I'm going to pull information from an API. I don't want to do it on the main thread. So I'm going to create a separate thread and I'm going to process it on that separate thread. And then so the CPU itself kind of treats those two threads as two totally different processes and kind of splits its time between those different processes. So that way your UI is still going to be responsive while this background process is still processing. The problem here is that these two threads, it's very difficult for them to communicate with each other because by definition, these two threads are asynchronous. So if I'm going to go collect data, now I can have, when that thread ends, it returns back to the main thread, and that can notify the main thread that something has been updated. And so now I can continue with what it has done. But let's say I am doing 10 different transactions, right? I'm pulling from 10 different API calls at the same time. Now, each of those API calls can report back to the main thread and update things. But no one of those threads will know if they are the last thread. In fact, none of the threads know the state of any of the other threads. The only thread that might know what the state of the other threads is the main thread, and that's only if the threads report back to it and it keeps track in its own way. What this does is it leads to race conditions. Let's say we have two threads. Let's say we thread the combat simulation. So now each and every attack in the game is on its own thread. That should make it more responsive, potentially, right? But what happens if there's a thread where I shoot you and there's a thread where you shoot me? Now, which one of those two happen? So like, you shoot me and kill me, or I shoot you and kill you. Whichever of these two resolves first gets the kill and will invalidate the other one. So now it isn't a matter of like an actual simulation. It's a race between these two threads to figure out which one finishes first. That's why we call it a race condition. My point is, there's only so much you can do when it comes to making these things asynchronous. Could just make them go through. Yes. However, my point is that if they're both updating the same state, or better yet, here's a good one. Let's say this thread is saying I'm healing you for 20, and this one says I'm damaging you for 10, and you're at 10 health. Well, if this one finishes first, you die, and the healing fails. If this one finishes first, you heal for 20, and then this damages you for 10, and now you're at 10. So that's another example of where, like, that's an actual example of like where that would be a problem. And again, like, I'm trying to give like really simplistic versions of this stuff. So obviously this isn't necessarily the way it's actually going to happen, but like, that's what a race condition is. The bottom line here is that a lot of processes have to be done synchronously. In other words, it has to be done, you know, one before the other, or at least this must complete before this can be done. Having things being processed on different servers is like the ultimate in asynchronous communication. Because like if this server is doing something and this server is doing something, the question then becomes, how much server processing are you going to expend to communicate these two servers' state? You're actually going to lose efficiency just trying to keep those two things working together if they're both interacting with the same thing. So things like the combat simulation isn't really something you can just, you can't just add more servers to a fleet fight and fix the problem. Thus, there are only two significant ways that CCP can do this. I mean, obviously there's the normal ways that we know of where they remap things to make it so that normally any given server blade has multiple systems mapped to it. But if they know that there's going to be a big fight, they'll actually remap everything off of that blade. So that way it's only working on that one simulation. So now we have the absolute highest amount of server power that we possibly can in processing that particular fight or system or whatever, like, right? Like that's the most we can do. That's the most power we can do to it. The only other things that we can do is either A, upgrade the servers, which they do all the time. Their servers are ridiculously powerful. They've done many different dev blogs in the past about, you know, every time they upgrade the servers, they post like dev blogs and stuff and show off like how like awesome their servers are. Like CCP servers are top of the line almost constantly, like almost prototype level of top of the line. And secondly, what they do is they have worked to offload as many functions as they possibly can off of the main combat simulation. So in this sense, like the main combat simulation is closer to that main UI thread that I discussed earlier. And so anything that doesn't have to be on that server, they have now started to move off to other servers. So two good examples of this. You remember when they changed local or like chat? And now like chat every once in a while has problems. I mean, not necessarily, it doesn't have as many problems as it did before, but the reason why chat can go down without the game going down is that they've offloaded the chat system to a separate server. So that system, because of the fact that they're two different systems, occasionally that connection can fail. Either the server that's running the chat or whatever, or doesn't communicate correctly, blah, 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 blah. So there was some issues when it comes to that transition to using or offloading that chat server. But it meant that the main server, guinea pigs, like the stream for the guinea pigs, the main server no longer has to process chat information. Another good example of this was a project that they called Brain in a Box. What they did was basically all of the state of like your attributes and you know, like your ship stats, like the actual like basically like your ship stats and like how your skills affect your ship stats, as well as things like boosts and stuff, like the actual like numbers behind the simulation. They've actually removed all of that from the main server and they've put it to its own system. So now there's an entire system that just maintains that state. And then the combat simulation can simply update and query that state whenever it needs to. So now that processing is not being done by the main server. So that's basically the only things that they can possibly do to make things better, is move things off of the main thread, off the main server calculations, which they continue to do, and improve the server architecture, which they continue to do. And of course, the third thing be, make it so that the server fails gracefully, which is what Tidi does. And then from there, of course, they're constantly hunting down inefficiencies within the code or, whatnot. There's plenty of stories of them finding things that are having problems, especially when, again, at those. One of the issues is that it's very, very difficult to simulate, to predict what actually happens at scale. Like, I remember when they created the thin client, which was like the very first things that allowed them to even test the server at scale. But I mean, like, this is why we're doing the mass test, right? Because in the end, they can test it as much as they want. But until we get 1,000 or whatever players connecting with all different kinds of machines, doing all different kinds of things that CCP may not even be able to predict off the top of their head, like, until we see that, then they have nothing to diagnose. And so they, every single fleet fight creates reams of logs, and every single fleet fight creates opportunities for them to improve things for the next time. And over time, things have gotten a lot better. I mean, every time they do bigger fights nowadays, I see people on Reddit complimenting how well things have performed. So one thing that they have difficulty with, they can't actually make the nodes smaller. If CCP could, they'd love to. Yes. Well, I mean, yeah. And that's the thing is that, like, the compromise is to restrict the number of people within the system. And that has its own problems. So how is it that we have less players than before? Servers have been updated and only do calls, and we still have tie-dye like we did 10 years ago. This makes no sense to me now. Because, first of all, whether or not we have more people than before, I don't know if that's necessarily true or not. But remember, we're talking about apex situations. Our capacity to field thousands of players in the game has not gone down. We continue to break records. As the server becomes more powerful, more people are able to contribute. The other thing that has happened is, especially in nullsec, the power blocks have pooled further and further and further as time goes on. And so while the concurrent player base has not gone up, the number of people that are in a system during the big fights has gone up. And at the same time, again, those fights have improved. The last several significant fights performed way better than any of the fights 10 years ago. I can tell you that. Because it doesn't matter how many people are there on average. It doesn't matter how many people are there across other systems. The only thing that matters is how many people are right there in that system doing stuff. And the player base has only gotten better at putting more people in a system to do stuff at the same time. Does that all track? Are we good? Hold on. Eve offline. So we can see here, like, this is 2015. Honestly, the number of people, the peak concurrent users hasn't actually gone down that much compared to 2015. Now, obviously, there was a bit of a dark time where we had blackout and scarcity and all that stuff. But, the numbers are actually not that bad. Like, we are currently in the summer, which always has a tendency to go down a little bit. Sorry for derailing the stream. I don't think that this is I mean, this is what we're here for, right? I'm here to put Eve into context for my fellow Empyreans. So if today we're talking about server architecture, then that's amazing. One thing that they could do is create a mechanic where multiple objectives need to be met at the same time in separate systems. Jeff, it's almost like you've stumbled upon the theory behind this the sovereignty overhaul from Aegis-Sov. Like, that is exactly what Aegis-Sov was like designed to do, was to break up those fights across multiple systems. Now, you still have Apex fights around structures, but yeah, like, that's one of the reasons why. I mean, like, Fozzie's, like, they wanted to break it up across the entire constellation instead of a single system, not just for server load, but also for strategy wise, right? Like, if everything's just an Apex fight, then now the guy who can drop the most Titans just wins all the time. And Fozzie-Sov was designed to make it so that it was more about flexibility and control over the space than the ability to just put a bunch of people on grid. But yeah, I mean, like, a big part of that was about server architecture considerations. Absolutely. Yeah, the big fights aren't about flipping a system. It's about removing a structure. That's absolutely correctly. Do they actually have to be completed simultaneously? Yes and no. So they appear throughout the constellation, and you have to be, they have a timer on them. So it's a lot like faction warfare, where there's like plexes across the place, and, you know, each one has to entosis it. So you will often be entosising across multiple systems at the same time. Yeah. Especially if you want to get it done in time. Or, you know, like, anyone that you're not controlling means that your enemy can be controlling it, right? Like, that's the whole theory. Cool. All right. Well, I hope this was useful to people. This was a good discussion. I appreciate you guys talking about it. Any other questions about it or whatever? Because despite Sov being decentralized, citadels are incredibly centralized compared to posses. Well, I mean, posses are the same way too. But I mean, like, the whole point is that, like, there are still Apex level fights. But, you know, there has been work in the past, a la Aegis-Sov, to make it so that it's not just about Apex fights. Not really. You'd run into problems trying to have 100 Titans in a pos bubble. I mean, okay, fair. Fair. Yes. Structures provide a larger zone of security than posses ever did. One thing they could do to break up the system node is to put planets in their own node and have an acceleration gate in high altitude that brings you down to low altitude. You could do that. However, so, like, if you split it so that way it wasn't just a server, like, a server wasn't just the system, it was also, or it was down to like a grid level granularity, that could work. However, two things. One, that doesn't actually fix the problem once everybody is on grid with each other. And two, you actually, remember, I told you that the single largest load on the server is transferring from one server to the other, because basically server A has to transmit all of the state to server B, and then server B has to kind of use that state to construct its own model of what's coming in and then add it to the simulation, right? So you're only going to have that happening more, and it's going to make it so that, like, imagine if warping onto grid, like, when you jump between systems, it can take different amounts of time. Like, when you're in that warp tunnel, that's basically trying to cover for a load window. Imagine if that was happening every single time you warp. Now, when you warp in, there is sometimes a hitch, but that is almost always client side. That's your client attempting to construct everything in space to visualize it to you, not the server. That would make it into a server problem, as every single time you move between grids, they have to transmit your data from one server to another, which, again, the servers are not able to be synchronous with each other necessarily, so they just have to always be ready to receive information from another server and add it to its own personal simulation. So you don't actually fix any problems, and you might make them worse. Yeah, I wouldn't make it so each grid was its own server, just thinking putting planets on its own servers. I mean, Vanguard. No. I mean, so back to what I was saying earlier, by the way, was that Amazon wanted to make their own MMO that was this kind of infinite, like, they bragged about this idea of, like, infinite scalability. And while it changed over time, that game, New World, was kind of the eventual end result of that effort. And as anyone who knows anything about it, knows, New World was a giant mess, especially when it first came out, but also completely failed to deliver on that promise, right? So even the best, the people with all the money and all the knowledge about server architecture failed to make this idea of like a scaling server that can handle any number of clients connected to the same point. CCP did hire some Star Citizen server meshing techs, by the way. Yeah, and a lot, I mean, like, that's, like, there's a lot going on, including, like, the dynamic server remapping and stuff like that, and things like Brain in the Box, right? Because if you think about it, Brain in a Box is a kind of server meshing, because you still have two servers. You now have the server that's managing statistical state, like the attributes, and then you have the server that's handling the current live combat simulation, and those communicate with each other, as opposed to before where they were both handled on one server. Yeah, Dogma is the system that manages all of the attributes. The point of the matter is that this happened in 2015. It was a very big deal at the time. And it also was buggy as hell. It was a hard transition, let me tell you. But, so yeah, I guess that's a little bit of information about kind of what's server side, what's client side, how these things interact with each other, and why Fire and Smoke is not causing tie-dye. Funny enough, so like a good example of this was the bounty system actually got accused of causing tie-dye. And even though CCP said that it wasn't, like they looked into it and it wasn't causing significant tie-dye, or like it wasn't causing significant server load, they did remove bounties because people believed that it was causing server performance issues. So that's true. All right. That's going to be a good segment. I've been Ashtarothi. I've been playing this game since 2010, talking about it since 2012, and I'm here to put even into context for you, my fellow Empyreans. Thank you guys so much for coming, hanging out, watching the video. But make sure to like, comment, and subscribe, because all of that is very, very helpful to the channel. And it's how we get this information out there and maximize players' knowledge and literacy of EVE Online, because a better player base makes a better EVE Online. And I've been Ashtarothi, the voice of New Eden. Until next time, I'll see you in space.